Before we start, I want to apologise for the sudden audio changes throughout the tutorial. I got a new microphone halfway through and I couldn't stand to bear any more of my old one. I also want to apologise for the length of the video. If you just want to mess around and don't care about making quests or anything like that, you can stop watching when we have the RuntimeCode.lua set up. The first half of this video will be a tutorial on setting up the workflow for modding Fable 2's Lua Scripts. The second half will mostly be relevant to mod authors. It will contain explanations of the systems you'll be working with in Lua if you do decide to create something. Without further ado, let's begin. Fable 2 uses a scripting language called Lua to drive things like quests, AI, UI, debugging and more. We can make use of this by adding our own scripts that can control the game, letting us make custom content or just mess around. This video will bring you through the process of getting set up so you can start making your own scripts and have your own code run in the game. It will be mostly aimed at those that wish to author content rather than those that want to mess around with things like free camera, invincibility and spawning NPCs. However, this does not exclude you. If you don't have knowledge of a programming language or of Lua, then you can still mess around with the debug functions. Just watch the video and do as I do, and you'll be able to simply copy and paste commands and press run. I'd highly recommend having a knowledge of Lua, or at least some kind of programming language before we start, as it'll make things easier to understand, I hope. Lua itself is a very simple language which can be learned with ease. In fact, Fable co-creator Dean Carter is creating a tutorial right now aimed at first-time programmers which happen to be in the Lua language. As of posting this video, I believe you can do the following with Lua alone. Create quests, create cutscenes, have some control over AI, and call many game functions which give you a lot of control over the game. For playing and testing, either the Xenia emulator or a modded Xbox 360 is needed, though at least a normal 360 is required to dump the game legally for use with Xenia. Here's some pros and cons each for using Xenia and using a modded 360. Xenia has many benefits as the game files can be manipulated directly on your computer and started up instantly. It is also guaranteed that you'll be able to modify scripts at runtime. I highly recommend using Xenia. It's simply much more convenient than using a 360. In the event of a crash, it is much faster to restart Xenia than it is to restart your Xbox. Xenia can also render the floor now, which was a major problem in the past, but isn't anymore. Xenia isn't perfect, however. It may crash when starting up, but I find this to be rare. There are also the occasional visual bugs, such as the hero and the dog's textures becoming pitch black. The dog's model can also explode. If your PC can't handle Xenia, that's also a pretty big problem. Make sure you're on the latest version if you do decide to go with Xenia, which I hope you do. As of recording, you need the latest Canary version of Xenia. A link will be provided in the description. Using a modded 360 should be possible, though I haven't tried it. I imagine there'd be a few hurdles. Instead of directly modifying the files from your PC, you'll have to transfer the modded game files or scripts after each modification. Like Xenia, you should still be able to modify scripts at runtime, thereby running functions and code on command. This can most likely be achieved through FTP. If you can't transfer files to your 360 over your network using FTP, you'll have to transfer the files and your scripts over USB, which means if you make a simple syntax error, you'll have to close the game every single time you want to test something. I really don't recommend this, as FTP will literally save you hours of restarting the game. So make sure you're using FTP. Now, you'll also need a copy of the game in its loose format, so you have access to the file structure. If you dump the game from your 360 using the aforementioned guide, you should already have the loose files. To tell if it's in a loose format, you should see a file called default.xex in the root folder. If it just says default, then you'll want to change your Windows settings so file extensions are visible, which can be done like so. You'll need the following software to get started. BNKExplorer. This is used to extract the Lua files from the game's bank archives. There are alternative applications out there, but this is what I'll use. If you use something else, the file structure may not be the same. This may lead to unnecessary confusion. You'll need CompileCompressReplace.py. This is my Python script that allows you to replace the game's Lua scripts that are in the bank files. You'll use this to mod the game. CompileCompressReplace requires Python 3.6 or later. Install this and make sure it automatically opens files with the .py extension. I wrote this in 3.6. I can't guarantee it works on any other version, but you can give it a try. You'll also need offzip. This is used by CompileCompressReplace to decompress the extracted Lua files. You'll also need DecompileAllLua.py. This is my second script that automatically decompiles all Lua scripts that you extract. This depends on unluac. This lets you decompile the game's Lua scripts so that you can read and modify them. More on this later. Unluac requires Java. Just make sure it's installed, otherwise you can't use unluac. Also, make sure you can call Java from the command prompt for convenience. If you can't, I'd recommend either reinstalling Java or adding Java to the path variable manually. There's an alternative program called LuaDec, but it doesn't work very well. DecompileAllLua doesn't use it, so just stick with unluac. Alongside unluac, you'll also need luac. This recompiles the decompiled Lua scripts to be put into a format that the game can read. You will not need to use this yourself, as CompileCompressReplace automatically interfaces with it and does all the dirty work. We also want an empty BIC file to replace the intro videos, which will save us a lot of time when we're starting the game up. Go to the description and download all of these now. Just keep them in your download folder for the moment. Halfway through recording the video, I realised I had to change one of the software requirements from QuickBMS to BNKExplorer. If you ever see QuickBMS mentioned anywhere, just replace it in your mind with BNKExplorer. We're quickly going to replace the intro videos first. Let's do this now. Go to the Game folder, Data, Art, then Videos. Rename the Lionhead_logo and Microsoft_logo files. You can just add a single character as I do. Copy and paste the empty BIC file to the Videos folder twice. Rename each copy to what the logo videos were called. That's it. Every time we start the game, you should go straight to the menu. Back to setting stuff up. Now we need to quickly open up offzip.zip and extract offzip.exe from it. Now we need to quickly open up BNKExplorer.zip and extract both files. Now we can delete the offzip and QuickBMS zips. Please follow these steps carefully. File structure does matter for now, though later you can move files and folders in any way you want. Just don't rename anything, ever. The tools and the game rely on file names of scripts staying the same. Now, we want to create a folder dedicated to modding the Lua files that you can put your tools and scripts in. I'm going to call it Fable2Lua. Within this folder, we're going to make 3 more folders. We'll name them this exactly: GameScripts, GameScripts_R, and GUI scripts. Now we want to get the Lua scripts from the game's bank archives. If you are not using BNKExplorer, the file structure may be different. You may not be able to decompile all scripts using my tool, though this isn't 100% necessary. Assuming you're using BNKExplorer, do as follows. Go into the game's folder and copy each script bank file into our tools folder. Open BNKExplorer. Now for each of the bank files we copied, open the bank file and click Extract All. While doing this, I encountered an issue where I couldn't open the _R bank. The _R bank isn't really important. The one we want to look at the most is gamescripts.bank. If I ever need to show you anything from gamescripts_R, it'll be on screen. Choose each bank's respective folder when extracting. All scripts within the bank file should now be in their respective scripts folders. We can now delete the bank files that we copied earlier. This is what you should end up with. Now we have all of the scripts extracted, but they're still compiled. This basically means that they're in a format that's fastest for the computer to read, which does not help us. Don't worry. This is where unluac and DecompileAllLua.py come in. To decompile a script, we can just pass it to unluac on the command line. There is a manual way to do this, but don't follow along, because DecompileAllLua does all of this for us. This is just an example if DecompileAllLua doesn't work. We could, Open a command prompt or PowerShell window in the folder that unluac is in. Type UNL and press tab, then drag and drop the script onto the window. You can use two greater than symbols preceded by a file name to specify an output file. Otherwise, the contents of the Lua file will be displayed on the command prompt window. This process is annoying, so as I mentioned, I've made a Python script that will automatically decompile every Lua script in the folders. Once again, the file structure matters for the next step, so make sure the folders are named exactly how I've named them. Simply drag and drop each folder onto DecompileAllLua and it will decompile all of the scripts for you. This script is not perfect and it probably has some bugs and may miss some files. Enum or type files may give an error, but that's because they don't actually need to be decompiled as they're plain text already. If the script fails, it should automatically copy the file anyway, so if you encounter a garbled Lua file, it's probably still in compiled form, in which case you can follow the previous steps that I told you not to follow. The output folders are labeled decompiled and are located within the folder you dragged onto the Python script. For GUI scripts there will be two folders named decompiled, but you can merge them into one by moving them into the same place. Now, we should make sure this has worked. Go into any decompiled folder and open a Lua script with the text editor of your choice. If you've chosen to open a file from GUI scripts or gamescripts_r, the code itself may not be easy to read, and you'll see placeholder variable names such as L0 and L1. This is actually not a problem. I'll explain this soon, but first let's clean up the file structure a bit. I'm going to move the decompiled scripts around so it's more convenient. Now we should back up the decompiled and compiled scripts. Let's do that now. If we mess something up, we can just restore these files. We can also rename and move any folder that we want, as file structure no longer matters. File names, however, do and always will matter, as the CompileCompressReplace script needs to know the name of the script so it can find it and replace it in the game. I'm going to delete these old compiled scripts as I have them backed up. We're very close to actually doing something now, but you need to understand which of these banks do what. I'll keep it short. Gamescripts_r contains gamescripts that control a lot of the game, quests, AI, etc. GUIScripts.bank contains scripts related to the UI. Gamescripts.bank contains the same script as gamescripts_r.bank, but with two major differences. The first is that gamescripts.bank doesn't seem to actually do anything. The second major difference is that gamescripts.bank contains practically identical scripts as gamescripts_r.bank, but they don't have their debug information removed. This is great for us. Remember that _r scripts have meaningless variables like L0 and L1? That's because their variable names, a part of the debug information, have been stripped by the Lua compiler. This is not the case for gamescripts. So we can look at gamescript scripts to understand what gamescripts_r scripts do. For example, compare a script from gamescripts to the same script from _r. You'll see that they do the same thing, but one is much more readable. This actually means that if we strip the debug information, we can turn a script from gamescripts into its _r version. This is very convenient because it means we can take a script from the gamescripts bank, strip the debug info, and put it into the _r bank. In fact, debug information being stripped happens automatically when you use CompileCompressReplace, so you don't need to worry about that. Catch any of that? I don't blame you if you didn't. Basically, we want to take scripts from gamescripts.bank, modify them, then put them into gamescripts_r.bank. Before we go any further, back up gamescripts_r, gamescripts, and GUI scripts in the game folder. If these banks get broken, you're going to have to redump the game if they're not backed up. Before we can write any code, there's one big hurdle that I must mention. Because we're going to be replacing files in an archive, the bank file, we cannot replace a script with a bigger script. I won't explain why, but it's just a technical problem that would result in overwriting the next file or files in the bank if it's too big. There is a couple of solutions to this. The first is to remove redundant code from the script. Some scripts have redundant code, like calls to the print function, that can be removed safely. This isn't the best guaranteed way of getting our code to run, because not every script has useless code that we can remove, and most of the time removing this redundant code still doesn't give us enough space to do what we want on its own. The second and better way requires a quick but very important explanation. Let me tell you my definition of internal and external scripts. All scripts within the bank file I call internal scripts. These scripts are automatically run by the game. For example, a quest script is within the bank file and is run whenever the quest needs to be loaded in. All scripts that are loose and outside of the bank file are external scripts. There's no practical difference between the code, just how the files are stored. We can actually run our own external scripts containing our own code by modifying an internal script to call it. This is what we'll be doing. Later on, we'll talk about a better way of loading our scripts once we already have our code loaded. But back to the issue at hand. The second way to solve the file size issue is actually quite simple. Basically, we move some of the code from an internal script we're trying to modify to an external script, and then run the external script alongside any modifications we want to make. We're pretty much swapping original code with our modded code, which could run the original code that now lies in an external script. If you didn't get that, it's okay. Just know that we can get around file size issues by putting our code and some of the game's code in an external script and running it. I'll give you an example while we're modifying our first file, which we'll do now. Now we can actually do something practical. The very first thing we're going to do is modify a script just to test that we've done everything right. For our first try, we can do something simple. We're going to add a call to a function that pops up a window and displays text. Right now, we just need to find the entry point for our first bit of code. I highly recommend starting with the GeneralScriptManager.lua script, located in the miscellaneous folder within the GameScripts bank. Let's copy that to our Fable 2 tools folder for quick access. Let me quickly explain that it doesn't matter which Lua file we write our code in as such, as long as the script gets run when we want it to. Remember that Lua is an interpreted language, and all code in the script gets run from top to bottom, assuming there's no return calls. For example, if we define a variable outside of a function and at the top of the Lua file, the variable will be defined, and it will be defined before the function. It will be defined in the environment that the script is in, which is probably the global environment. Take a quick look at GeneralSetupscripts.lua. As we can see, it basically loads a ton of Lua scripts. As far as I know, this happens once at the beginning of a new game. That means we can add our code to any of these scripts and it will get run once at the beginning of a new game. Let me emphasize that these scripts being run only once means that they will only get run once. All of these scripts simply define things. Once they are defined, Lua will save them. All of the things they define persist between saving and loading, and so if we were to reload a save, these scripts will not get run again. They will never be run again, at least not in the save file. But don't worry, that's not as bad as it sounds. I've come up with something that lets us run code on command, but that's for later. Do keep in mind that these scripts are run in order, and so GeneralScriptManager is run first and breadcrumb trail is run last. Therefore, if a function was defined in breadcrumb trail and we tried to access it from GeneralScriptManager, we won't be able to, as breadcrumb trail simply hasn't defined it yet. Now, back to GeneralScriptManager.lua, which is the file we'll be modifying. This script controls the saving, loading, and execution of some coroutines. I've chosen this script as it has some redundant code that we'll remove and replace with a function call that will run an external script. We won't do that quite yet, because we want to make sure we've done everything right so far. For now, we're going to do as I said and add a call to a message box function. Like I said earlier, we can't add a bunch of code just like that due to file size limits, so let's find some redundant code first. As you can see here, we have some print calls. These can be removed as the print function doesn't do anything. We can also remove this if statement, as it only leads to a print call. Now we've made a tiny amount of room to write something, but only barely. I highly recommend writing exactly what I write, because we have such little room, and writing too much will result in an error later. Okay, let's write that message box call now. From what I can tell, this whole script gets run, and there's no chance that it ends early, so we can just put the function at the end of the script. Write what I write. Now let's use CompileCompressReplace to put the script back into the game. In the future, you should make a batch file to automatically give CompileCompressReplace the files we're about to give it. But this isn't necessary, as we won't be replacing scripts much longer. For now, we'll run CompileCompressReplace manually. I'd recommend opening command prompt for this, as if there's an error you'll be able to see it instead of the window immediately closing. You can also just press the up arrow key to repeat the previous command, which will be the command to start CompileCompressReplace if you need to run it twice. Shift and right click the Fable 2 tools folder. Click Open PowerShell here, or Open Command Prompt here if you have that enabled. If you opened a PowerShell, just type CMD, then CLS to clear the screen. Type compile and press tab to autofill CompileCompressReplace. Press enter after dragging each of these onto the window. First the Lua script, then Lua C, offzip, and then gamescripts_rbank. Remember, whenever we're modifying a file that's from either gamescripts bank, we want to put it in the gamescripts_rbank, as the non-rbank is pretty much a dud. If you get an error, read it and try and figure out what's wrong. If it's telling you that the new file is bigger by X amount, and it's saying that's bad, it's because the script you're giving it is bigger than the original unmodified script. In that case, press N, as continuing will probably cause the game to crash when loading in, and you'll need to restore your old bank file. If you followed everything exactly as I did it, you should have no problem. If you followed everything I did and still got a warning about the file size, try changing Hello World to simply Hello. Now let's start the game. If you're using a modded 360, you'll have to transfer the gamescripts_rbank to it, and overwrite the original. Moment of truth. As you can see, we finally did something. Not much, but something. If the game crashed, it's probably because a bank file was broken, or your code has caused it to crash somehow. If you're using Xenia, it may have just been bad luck, so try again. In this case, delete the bank you modified, which should be gamescripts_r, and restore the original and repeat the steps. Make sure you don't lose your backup. Now that we want to do more, we're going to add a call to run an external script, which can contain as much code as we want. Go to Fable 2, Data, Scripts, and create a new file. Note that we want the scripts folder and not the scripts_r folder. This is contrary to how the bank files work for some reason. Now, because of the file size limitation of the internal scripts, we should keep our new external scripts file name short. If necessary, we can name it a single character without a file extension. As long as the file contains Lua code, it will work. Fortunately, we have room in GeneralScriptManager to give it a decent file name. I'm going to call it CodeLoader.lua. I'll get onto why we call it this later. Now go back to GeneralScriptManager.lua and move the GUI.displayMessageBox call into our external script. Now we need to run our external script by adding a call to a function that will load it for us. There exist two functions we can use. One is called loadFile and the other is called runScript. For now we'll just use runScript and give it a full path relative to the script folder. Now we need to quickly rerun CompileCompressReplace. Simply press up on your old command prompt or PowerShell window and press enter. Remember, we need to do this because GeneralScriptManager isn't an external script, and the addition of RunScript hasn't taken effect, as we haven't put GeneralScriptManager back into the bank yet. This will be the very last time we're going to be replacing a script in a bank, unless you plan on modifying another existing script, like a quest. And there we go. We now have code running from a plaintext file outside of a bank without having to use CompileCompressReplace to get it running in the game. But what if we want to run or change code on demand at runtime? It'd obviously be very convenient, as right now if we want to run code we'd have to restart the game and make a new save file. I have a solution. I made a script that lets us run code on command. It's called RuntimeScriptLoader. I've left a link to it in the description. Copy and paste the contents of it into our external script, overwriting our earlier hello world function. The script may look a little different from the video, as I may release updates for it on the GitHub page. We're going to modify this in a moment, but first we need to make another external script. Go back to the scripts folder and make a new script. We should call this one something like RuntimeCode.lua. I'd recommend you name it that too. Now go back to the CodeLoader.lua file. First, we should change the path that's given to the runScript function to whatever our new runtime script is called. Of course, if you named yours RuntimeCode.lua like I did, then enter that. Conveniently enough, that's already there. Now open RuntimeCode.lua. We must create a specific variable and a specific function in our external file for the RuntimeScriptLoader to work. Create the value called myTestTable.newChecksum and assign it as 0. Now create a function called myTestTable.CodeToRun. Basically, whenever we change the checksum value in this script, the CodeToRun function will be called. Make sure never to have anything else outside of CodeToRun aside from the new checksum statement. This is because this script technically gets run every 2 seconds, and so if you were to put, for example, a function call outside of CodeToRun, it will get called every 2 seconds. Time to test it. So now we have the ability to run code at runtime on command. Changing this number manually is a pain though. I've personally set up a script on my text editor that automatically changes the new checksum value in the currently open file when I press a key combination, so I don't have to manually change it every time I want to run code. I did this by setting the text editor's build system to point to a custom application that simply reads the current file to find the new checksum value, then randomize it. I'd recommend you do this too if you're programmatically inclined, as all I have to do is press Ctrl and B instead of modifying the checksum and saving. Something important that you will probably find out even if I don't tell you is that if you pass some functions the wrong arguments, the game will crash. Generally, it's best to see if a function is used somewhere in a Lua script to see what you should pass it. To streamline this, see if you can add the decompiled scripts folder to your text editor or IDE as a project or something similar. This should index the files, highlighting the definition and references to functions in other scripts. If you can do this, it skips the needle in a haystack search of trying to find a script that uses a function so you can figure out how it works. It should also autofill when you're typing in a function or string. SearchTools is a very convenient way of finding entities within a map. It's actually quite powerful. When you search, you can filter by an entity's name, position, EC type, which we'll get to in a moment, and most importantly, by script. When you filter by script, you pass a function as the second argument to the search. The search will then pass your function every entity in the level, one at a time. You can then perform comparisons on the entity it passes. If the entity fits whatever it is you're looking for, you return true. If it doesn't, you return false. When you return true, the entity will be added to a table which is returned when the search finishes. For example, say we're looking for every entity on the level that is in the bandit faction. We can use faction.getCurrentFaction on the entity we've been passed. We then compare this to efactionID.faction_bandit. If true, return true. If false, return false. When we get the results of the search, a table containing all bandits on the level will be returned. What you do with this table is of course up to you. You could replace them with chickens if you wanted. Now I'll explain what I think EC type is. I'm pretty sure EC type stands for Entity C Type, C being the programming language. Everything seems to have an EC type, including things as simple as lights and doors. With it, we can search for every type of thing in a level. If you wanted, you could search for every light and change their close and brightness, or find every door and open them. For those that just want to mess around with debug functions and the like, that's all you need to know. To see what functions you have at your disposal, I made a huge list of interesting tables and functions, including some that aren't referenced in any Lua scripts. I also made a function that prints everything within a table to the screen, so you can see what's within a table. A link to both of these are in the description. The rest of the video will be talking about Fable 2's specific systems such as saving and loading and quests. Now it's time for some more confusing explanations that you really should know if you want to make something. Sorry. GeneralScriptManager is one of the game's scripts that manages a lot of coroutines that don't fit into the quest category, or any other category for that matter, scripts that should keep running no matter what. Its purpose is pretty much to run each coroutine every tick. Whenever a table is passed to a function called addScript, it assumes there's a function called update within the table. It then creates a coroutine and then stores it as co_update in the very same table that it was passed. Here's an explanation of what it does to update every coroutine each time. GeneralScriptManager creates a chain of scripts and traverses them, running coroutine.resume on each coroutine each tick if the coroutine isn't dead. The theory behind the way it creates the chain is pretty simple, though putting it into words is a bit tricky, so bear with me. I'll do a short explanation, then a long explanation. If you don't want the explanation, I'll have a timestamp for you to skip through in the video, though I recommend you listen to the short one first. Basically, for every script that is added, the function adds two references to the scripts table, the previous and next script. These are synonymous with the previous script that was added and the next script that was added. This way it makes a chain. One script references the next and so on. During the script update process, GeneralScriptManager goes from one script to the next through this chain of references and calls coroutine.resume on each one. Now for the long explanation. Whenever a script is added, it stores the table it was passed in a table called currentlyRunningScriptsEnd. This table only contains a variable called prev and the table that is being added. Prev is the previous script that was added. In the event that a new script is added, currentlyRunningScriptsEnd is turned into currentlyRunningScripts. At some point during the update process, it adds the variable called next, which contains a reference to the next script that will be added. At no time is more than two scripts directly referenced by GeneralScriptManager. During update, it basically gets the end script and works its way back through the chain that was created by the previously mentioned process of adding references to the next and previous script. In summary, just know that GeneralScriptManager creates a coroutine from the update function in a table that's passed to it and resumes it every tick. If you look at CodeLoader.lua, you'll see that the main function is called update, and at the end of the script, the table is passed to the addScript function. Of course, if you want to make your own quests or something, you'll want to look at the quest scripts and the questmanager.lua script to see how it all works. For that, I'd recommend a decent knowledge of Lua, as metatables, metafunctions, and function environments are involved. Understanding the saving system is vital if you want to create something that continues to exist when saving and loading a file, like a quest or a script that you want to persist, or pretty much anything for that matter. Knowledge of Lua is pretty much necessary for understanding this. Fable 2 uses a Lua library called Pluto, which impressively serializes anything in the Lua universe, as it's put, effectively letting the game create a snapshot of the Lua state and then write it to a file. This includes the serialization of coroutines and their current position of execution. Let's take a look at saveload.system.lua first. The main things to look at are getSaveTable and loadScriptSave. These functions do the inverse of each other. You'll see what I mean in a minute. So let's look at getSaveTable. This function returns all of the tables that are located within other certain tables. As you can see, it calls functions in the Quest Manager table, AI Manager table, GeneralScriptManager table, and Camera Manager table. For this example, I'll only talk about GeneralScriptManager's saving and loading process, as I believe it's the same for the other script managers, like Quest Manager. Let's look at GeneralScriptManager's getSaveTable function. It basically returns all of the tables that contain a coroutine that GeneralScriptManager is managing. When getting the save table, it just goes through the chain of script references and adds each one to a big table, the save table, which it returns at the end. As you can see, the saveload system script gathers all four of these save tables from all four managers and puts them in a single table, which it then returns. I can only assume that this table is then serialized and written to the save file alongside everything else when the game saves. I won't mention the permanence table in detail, as you probably won't use it, but as far as I know, it's used to prevent certain things from being saved that don't need to be. Now let's look at load script save. You'll notice that this function is passed a table, one that is identical in structure to the one that we just saw being created with the help from GeneralScriptManager. Once again, we'll have a look at what GeneralScriptManager does with the table it's passed. Ignoring those print calls and other things, the function simply gets every table that's in the save table and recreates the script chain by passing it to the insert function. There's a tiny bit more to it than that. There's a problem, which is a result of the way GeneralScriptManager saves the scripts it manages, or more specifically, the way it doesn't. Loading from saves was probably the second biggest hurdle I've overcome when figuring this stuff out. It's absolutely worth knowing that tables don't have names, they only have references, of which there can be an infinite amount, each of which could be named different things and exist within any table. In the RuntimeCode.lua script, I define a new table and add a reference in the global table as myTestTable. One very important thing to know is that after loading a saved game, assuming we only use GeneralScriptManager.addScript to create a coroutine, the only reference to the script will exist in the script chain, unless other scripts that have been saved also reference it, in which case a reference will lie within those tables. I didn't put that so well, so let's take my CodeLoader script as an example. All of this script's variables and the update function and coroutine are stored in a table referred to as myTestTable. The reference to myTestTable within the global environment is not saved when saving the game. This is due to the fact that, from what I know, only things that are in the manager scripts are saved from the Lua state. In this case, there are only two ways to reference myTestTable upon loading. The first way is through the use of the self variable. This is simply a reference to the table that the given function resides in. In CodeLoader's case, self refers to the table that contains our update function, which upon creation we referred to as myTestTable, though it is no longer called that after reloading the game. Upon loading a save, we can still refer to the table that the coroutine is within through the usage of the self variable. The second way is through accessing the GeneralScriptManager script chain itself. This is almost certainly something you should never do if you can just use self instead. When GeneralScriptManager is resuming a coroutine, it stores the coroutine's table in the currently running scripts variable. This means that when our coroutine is updating, and only then, currently running scripts is a reference to it. I chose the first way of referring to the myTestTable table, as it's the most reliable way to refer to the table that a function or coroutine is in. The coroutine simply checks to see if the global variable called myTestTable is nil occasionally. If it is, then it assigns self to it, thereby restoring the reference to the global table, just how it was when we first created the table. I must specify that the self variable is only usable in functions that are defined and called with a colon instead of a dot. For example, myTestTable.update would not be able to use the self variable, however, myTestTable:update would. There is a small caveat to that, but I won't go into it. In general, when you create a coroutine, you should always just use the colon. In summary, if you create a coroutine through addScript, the coroutine and its table and all the values within will be saved and loaded, but the only references to it that will be restored are those in other scripts and in GeneralScriptManager itself. For example, myTestTable is created in the global table and a reference to it is added to GeneralScriptManager. When saving, only the reference in GeneralScriptManager will be saved. And so, upon reloading, only the reference in GeneralScriptManager will be restored. To prevent any issues, your script should take and refer to the self variable as much as possible. If you must refer to the script table outside of the script itself, make the script check to see if there's a reference wherever you want it, and if it isn't there, add it. That's what I made the CodeLoader do, because the external script that it runs assigns the new checksum and code to run values to the myTestTable table, which is accessed by both scripts, and as such a global reference is required. I'd recommend you look through a quest script, anything starting with QC in the quests folder, and the quest manager script. It is relatively complicated, but I think the game manages most of the complicated stuff anyway, so I don't think you need to know exactly how the system works to make a quest. Quests are created using Lua's module system. This means its function environment is set to a new table, but it is also given access to the global table. I won't go into detail on function environments, but here's a quick explanation. Basically, if we define a variable without changing the function environment of the function doing the defining, the variable will be defined in the global table by default. If we set our function environment to a new table, the variable will be defined in that table instead, and can be accessed by just typing the variable's name. Setting function environments can be dangerous if you don't know what you're doing, but since you'll be using the game's built-in quest loading system, there will be no danger. Before we talk about instances of quests and NPC threads, I need to quickly mention Gameflow. Basically, Gameflow controls the order that quests are started in, starts quests and optional quests, including jobs, and similar things. When the game gets to a point where a certain quest should start, it accesses script.enum, whatever the quest name is, to get a quest ID. You will need to set one for your own quest. Basically, there's a bit of setting up you need to do before starting your quest script. I won't go into any more detail about this, so I recommend looking at gameflow.startNewOptionalQuest and gameflowbase.startQuest. You'll probably have to call one of these two to start your own quest, probably the startNewOptionalQuest function. Here are the basics on entity and quest threads that are created in each quest table. Both quest threads and entity threads are very similar and are both managed by the quest manager's update function. Before anything happens, the game calls the quest script, which we can find in the game's banks. When the game runs the quest, it makes a table and does the following with it. First, the quest script calls new entity thread or new quest thread, which is passed a string. This function creates a table named whatever the string was, and stores a reference to it in the quests table. I'll refer to this table as a thread base, as it is not a thread yet, and is instead a template that can be duplicated and applied to multiple NPCs. Then, the quest script adds functions and variables to the thread base, like an update function, init function, or a function that gets triggered when the NPC is interacted with. The quest then calls startNewEntityThread, which takes the thread base, makes an instance of it, and ties it to the entity whose name is specified as an argument. I believe if there are multiple NPCs with the specified entity name, the quest manager attaches instances of the thread to each of them. The quest manager contains an update system, identical to GeneralScriptManager's update system, but with a variable called currently running quests instead of currently running scripts. The thread, whether it's an instance of a quest thread or an entity thread, which I reiterate are mostly identical, can be accessed by passing its name to questManager.getQuestInstanceWithName. I'm not entirely certain on how the NPCs are created when quests are loaded, but I believe I know how. Each quest NPC is on what is called a layer. A layer is just a scene on the level composed of different objects, NPCs, and so forth. When the layer is disabled, all NPCs created by the layer are removed. While we do have the ability to activate and deactivate layers, we unfortunately don't have the ability to create our own layers yet. I believe that is down to the level editor, which nobody has recreated so far. This doesn't mean we can't spawn NPCs though. We can spawn NPCs ourselves by using debug functions. There are two functions. One is createEntityFromID at, and the other is debug.createEntityAt. Debug.createEntityAt takes a predetermined entity name that is already defined in the game file somewhere, for example, creature, fauna, chicken. Entities that we don't have the name of to pass to the function are a lot trickier to spawn. I don't know if every entity has an entity name that can be used for spawning. I've found some entity names in the GDB files, of which there exists multiple across each level file. If someone were to reverse engineer these files, perhaps we would be able to get all entity names. As for the entities we don't have the names of, we can use createEntityFromID@. Every entity has an ID that doesn't change, so if we can find it, we can use that instead. But IDs aren't just strings or numbers, it's user data, which is basically something we can't create ourselves in Lua. And so to get an ID, we need the NPC to already exist so we can get it from there, Not only that, but IDs, while they do persist between areas and saving and loading, can't be used to create an NPC while the level they were spawned on is not loaded. And so, IDs can really only be used to duplicate NPCs that already exist. As I briefly mentioned way back when I was explaining file size limits when replacing files, you can't just add code to scripts due to file size constraints. To get around this, we must add our new code to an external script and then run it. For quests, however, we can't just call RunScript to run our external script, because the function environment won't be correct for the code in it. For example, let's look at the quest script QC110 Road to Westcliff and the QC110 Teresa custom update coroutine at line 494. Say we move the if statement onto the external script, so say we can modify the distance that the hero needs to be for the cutscene to play, and perhaps even the cutscene that gets played. I chose this if statement for demonstration purposes. You probably wouldn't modify this specifically. So why can't we use RunScript? A couple of reasons. Self isn't defined in the external script, and so we wouldn't be able to use it to access functions and variables. Also, without self, we can't use it to refer to the instance of the table. Not only that, we can't access local variables from the script. Here, charge marker is a local variable which would not be defined in the external code, so we can't reference it. And lastly, while very rare, let's say a function tried to define something in the environment of the script that called it. The variable would instead be defined in the global table and not the quest or entity table. Thankfully, Lua provides two functions that prevents environment-related issues in this scenario. The first one is loadFile. As a reminder, loadFile doesn't immediately run the script. Instead, it returns the entire script as a function. The second function Lua provides is called setFenv. We can use this to set the external script's environment to the quest's environment. By combining these two functions, we can load the script, set the environment of it to the quest environment, then call it. This results in the code being run, for all intents and purposes, within the quest script. While that solves the environment issue, this doesn't let us use self, nor does it let us access the local variables, as the code is still in a different scope. We can't really change the scope of the external script, but there is a workaround. It's extremely simple. We simply pass self and any local variables that need to be accessed to the function that loadFile returns. The way we access the variables that are passed is through varargs, or variable arguments. When there is a function that is defined with 3 full stops as the arguments, that means the function can take a theoretically infinite amount of arguments. In the case of loadFile, the function that is returned is created with varargs. This means that you can pass variables to the script, including self and any local variables. Varargs can be accessed from within the function being called with the select function. Simply pass the select function 1 and ... The select function will return multiple values at once. To receive multiple values at once, write the variable names that will receive the values separated by commas. The values will be returned in the same order that you put them into when calling the script. I'll keep this brief as I lack the knowledge to explain what it is. It seems that every entity, effect, sound effect, and so forth, basically anything you can see or hear, has a record. A record contains information about the entity that the record is from. Records seem to be stored in the GDB files, or so I'm led to believe due to the fact that the function that returns records is gdb.getRecord. Also, if you open a GDB file with a hex editor, you'll find record-related data strewn about. The getRecord function can be passed an entity or a string. Records can have subrecords, which I imagine are like components making up a whole. You can access specific details about a record with the following functions: getFloat, getString, getS32, getU32, getEnum, getBoolean, and probably a couple more I'm missing. The interactive cutscene mind script demonstrates them. There is another Lua script that does demonstrate the kind of info that a record can contain, called behaviour receiveGift.lua. In it, we have a function called refuseRing. The function gets records of components from an entity, then information about the components with the aforementioned get functions. The problem is that I can't really figure out what data we can get with these functions, as there doesn't seem to be anything obvious displayed anywhere, aside from what we can find in the Lua scripts. Here's some other details about the game's Lua implementation that may or may not be useful. The global table has a meta table with 2 meta methods, index and newIndex. Index refers to a table called base objects. New index refers to a table called Fable2 scripts. This means that whenever you assign a new variable, it will instead be assigned in the Fable2 scripts table instead of the global table. And if you try to access something in the global table and it isn't found, Lua will then search the base objects table. I don't think this really has an effect on anything, but just in case this does happen to have an effect on something you're making, you should probably know. So that's pretty much it. You now have the ability to write Lua code and have it run within the game. You should now also have the ability to read through the game's Lua scripts to learn about specific systems and how they work. If you have any questions, leave a comment and I'll most likely reply. Thanks.